Bonnet Bakery is the one we're working on. As you can see from our objectives, students are going to be collecting some data representing a direct variation function and a situation represented by an inverse variation function. Students represent both functions using graphs, tables, verbal descriptions, and algebraic generalizations. Students will also be comparing and contrasting characteristics of these two functions. So we got two different things going on today. And if you look at your paper there, you'll notice that you've got two different situations, and we'll be working on both of those situations here in a little bit. But let's take a look at the scenario that we're going to be dealing with today. Now, we've got this bakery called the Blue Bonnet Bakery, and it makes some muffins. Now, notice here it says that each batch will make 24 muffins. The muffins are so popular with customers that at least 15 batches are made every single day. Now, if you look in your notebook, guys, a couple of pages after Blue Bonnet Bakery, you'll notice on page 42 there. Look at page 42.
Wasn't there another one?
Page 42. What do you notice on page 42?
Muffins.
The muffins. How many muffins do you see there?
The 6 times 4, 24.
You see 24 muffins. What do you call 24 muffins? We call that a batch. That's what they're calling a batch here. So that sheet that has those 24 muffins, that is a batch of muffins. So a batch of muffins contains 24 total muffins. We need to keep that in mind because that's going to come in handy in a little while, okay? So how much is a batch of muffins?
24.
24. Also notice here it says that it's so popular that every day they need to make how many batches? 15. So think about that. They're making 15 batches every day. And how many muffins are in the batch, do we say?
24.
So how many muffins altogether they're making every day?
360.
360 muffins every single day. That's how many they're making. Keep that in mind. All right, so like I said, there's two situations that we're going to be working with. We're going to start with the first situation. That's the left-hand column on your paper there. Now, the situation says that the owner of the Blue Bonnet Bakery wants to analyze the relationship between the number of muffins and the number of batches made. This will help the owner determine the amount of ingredients to purchase and predict future needs of the bakery. So, right here, they want to know, or actually it says here, they want to analyze the relationship between the number of muffins and the number of batches made. So the first thing we're going to do is identify what the independent and the dependent variables are. One depends on the other. The question is, which one depends on the other? Is it the number of batches that depends on the number of muffins, or is it the number of muffins that depends on the number of batches? All right? That's what we've got to determine. What do you say? Batches what?
Oh, no, it's
Or you're going to say batches. All right, independent and dependent. Our independent is going to be the number of batches.
the batches.
The dependent is going to be the number of muffins. In other words, the number of muffins we have is going to depend
On the number of batches we have.
on the number of batches. Obviously,
I like that
the more batches we make,
Batches.
the more muffins we're going to have.
Uh,
So how many muffins we have depends on how many batches you make. All right, so now we know what our independent and our dependent variables are. Now let's talk about the domain and range. Now we're talking about actual values, some numbers here. Domain, the x's, which in our case, those x's represent the number of batches. Go back to the very top of your page there. What did it say about the number of batches up there at the top? Everybody look, you're looking at me. I want you to read your paper. What does it say on your paper about the number of batches? That they're so popular
Did they get 15 a day?
that they have to make 15 every single day. Are they ever going to make less than 15 batches?
No.
No. So our domain is always bigger than
15.
15. That's what we need to write here. So let's do that. Our x values are always going to be greater than or equal to 15. They're never going to make less than 15 batches in a day. Otherwise, they wouldn't have enough. 15 batches every single day. Now let's talk about the range, the y values. This time we're talking about the number of muffins. How many muffins are they making? Well, y values. we say earlier, every day they make
360.
15 batches, which means what?
360
Where do you get 360 from?
times 24 times 15.
Yeah, each batch has 24 muffins, so if you multiply 24 times 15, we have 360, which means every single day we have at least 360 muffins. Every single day we're going to end up with 360 or more muffins. So the domain is anything greater than or equal to 15. The y values are anything greater than or equal to 360, the number of muffins. Okay, the next thing we want to decide is, can we call this a function? Well, first of all, function. What did we say a function was? When the x's, what? When the x's don't repeat. So, can I call this a function? Yes,
Yes.
or no?
Yes.
Yes, we can. And why can we call this a function? Because the x's won't repeat. Each x has one unique y. In other words, if I make 15 batches, I'm going to have 360 muffins. If I make 16 batches, am I still going to have 360 muffins?
No.
Of course not. I'm going to have another unique y value. If I make 17 batches, I'll have another unique y value. So I always get something different from my y based on my x. Next one. Do we have an increasing or a decreasing relation? What do you think? Increasing or decreasing?
Increasing?
Increasing. Why would you say increasing?
Because the more you get, the bigger the number, the range.
Oh, okay. So the more batches we make, the more muffins we're going to have. Very good. So yes, it's increasing. And the reason it's increasing is because as each x increases, the y is also going to increase. In other words, every time we increase the number of batches, we're also going to increase the number of muffins. As one gets bigger, so does the other. This is why we have an increase. All right, the next thing we want to determine is, do we have a continuous or a discrete relation? So, first of all, continuous and discrete. What was the difference here? One has the points that are connected, one has the points that aren't connected. So the question is, which one's which? Continuous. What's
Goes
that?
on.
What?
Goes on.
Well, it does go on, but what do we know about the points? Continuous. Are they not connected or not connected? They are connected. Okay? Discrete means that they are not connected. So what can we call this? Continuous or discrete? Can we connect the dots, or we're not supposed to connect the dots? What? That's right. This is discrete. We cannot connect the points. Let me let you write this down and I'll explain why we cannot connect the points. This is discrete. The reason we're not going to connect the points is because we need to keep in mind what we're talking about. We're talking about muffins. And we cannot have a part of a muffin. You can't go and make 2.5 muffins. You can make 2 muffins, you can make 3 muffins, but you can't make 2.5 muffins. We can have 12 muffins, but we can't have 12.5 muffins. There is no partial muffin, which is why we're calling this discrete. If we were to call it continuous, that would mean that we'd be including part of a muffin, and that's just not true. Can't have it. All right, what you're going to need to do now, guys, is turn to the next page. We're still looking at the left-hand column. Next page, left-hand column. This is still the first situation. Now what we're going to do is we're going to fill out this table here. Now, in this table, we need to keep in mind that our x value, the x values or the independent are the number of batches. The dependent or the y values are the number of muffins. So if you look at the table here, that one you see there represents one batch. If I had one batch of muffins, How many muffins would I have?
24.
24. Fill that in. 24. What if I had 2 batches? How many muffins would I have? 48. What if I had 3 batches?
72.
70. What?
2.
2. Let's keep going with that. What if I had 4? 4 batches.
96.
4 batches would make
96.
96. 5 batches would be
100.
120. Let's do one more here. 6. What if I had 6?
144.
144.
44.
Now notice that last one down there. All they gave me was an X. Well, let's think about this, guys. This 144 that you have here next to your 6. What did I do to get to that 144?
Times 24.
Times 24. So all we're doing is multiplying the 1, the 2, the 3, the 4, the 5, and the 6. And we're just multiplying them by 24. So I'm going to do the same thing down at the bottom. All I'm going to do is multiply the 24 times the X. And what do you get when you multiply 24 times an X?
24.
You get a 24X. So the last one you should have down there is 24X. All we're doing is taking the X value, whatever it is, and multiplying it by 24. Because that's how many muffins are in a batch. What we're going to do now is we're going to take this table of values and we're going to make a scatter plot, create a graph. So we've got this graph that we have here, but we're going to have to label some things first. First thing I want to do is label my x-axis. What do those numbers represent? What does that 1, 2, 3, 4, 5, and 6 represent?
The Y? No, it represents the batches.
It represents the number of batches. So let's put that down here. It's the number of batches. Number of batches. Those are what the x's are. The y values, that 24, 48, 72, 96, what do those numbers represent?
The number of muffins.
Number of muffins. Here it is, number of muffins. So now that we know what the x and y's are, now let's actually use some numbers here. We got to put some numbers. What are we going to count by? Let me start with these x's down here.
10.
Notice over here on the x's, we were counting 1, 2, 3, 4, 5, 6. So the last one we have is 6. So what would be a good scale? Or what should I count by here?
1.
Ones. Let's do that. 1, 2, 3, 4, 5, 6. Perfect.
2 is the next one. 10.
Now the next one, if I try and count by ones,
24.
obviously I'm not going to get to that 144.
We go by 24.
So let's do something else. What?
24.
24. If I count by 24s, will that get me all the way to 144? Let's try it. We have 24, then we have what? 48, 72, 96, 124, or 120, and then 144. That works out perfect. So now I know what I'm going to be counting by. Now all I got to do is take each of these points and plot them. So the first order pair we have is 124. So let's find that order pair 124 and put a dot. Then we're going to find the 2 48s. Then we'll find 3 72. Then we'll find 4 96. 5 120. And then 6 144. Well, look at that. Perfect. That works out just perfect. By the way, notice I did not connect the points. So make sure on your paper you do not connect the points. What is it called when you don't connect the points? Discrete. And what did we say earlier this was? What did we say, Johnny? That it was discrete. And the reason we're calling it discrete is because we can't have part of a muffin. All right, we're almost done with this first situation. They want us to write a verbal description for this situation. So here's what I want you to write for me. The total number of muffins. Total number of muffins increases by 24. Total number of muffins increases by 24 muffins per batch. total number of muffins increases by 24 muffins per batch. In other words, every time I make a batch, I end up with 24 more muffins. Every time we make a batch, we're increasing the number of muffins by 24. The last thing we're going to do is write an algebraic representation. So now we're going to take that statement and see if we can't write a rule or a function that describes this. Okay? So anybody want to take a stab at it? What do you think? What's the rule? I'll give you a hint. Y equals something.
Y equals 24x.
Huh?
Y equals 24x.
All right. Perfect. Now, if you were paying attention, guys, that was actually given to you. Does anybody know where I can find that 24x?
On the chart.
In that
Table thingy.
table right here. Because think about it. How did we get these y values over here? The way we got the y values is simply by multiplying the x's by 24. That's our rule. How do you get y's? Take the x's and multiply by 24. All right, so that takes care of the first situation. It's going to get a little trickier on the next one. So let's turn back to the first page, and let's take a look at the second situation. A little bit different. On the second situation, it says that the oven goes out. So the oven breaks. And they were only able to make one batch. That's all they made. Now let me ask you, if they only made one batch, how many muffins did they make? 24. So all they have to sell is 24 muffins. That's it. 24 muffins. Now it says here that there are several customers already waiting for those muffins. The owner wants to analyze the relationship between the number of muffins each customer will receive and the number of customers if he splits this batch. Okay? So again, we're analyzing the relationship between the number of muffins each customer is going to receive and the number of customers that split this batch. So here we go. Independent and dependent. Independent and dependent.
Number of customers.
Independent is going to be the number of customers. Independent is the number of customers. The dependent is going to be the number of muffins per customer. Dependent is going to be the number of muffins per customer. In other words, the number of muffins you get, is going to depend. What does it depend on? The number of customers. Think about it, guys. If there's only one person in line, just one person, how many muffins are they going to get? Well, they can get all. Remember, they get them by the batch here. But right now, how many muffins do we have? 24. So they get to have all 24. But what if there's two people in line? Do they get all 24 each? Of course not. How many do they get?
12.
They get 12 each. So the more people that are in line, what?
The less muffins you get.
The less muffins you're going to get. Makes sense, right? Because there's only 24, and we got to split it. So keep that in mind. That's going to come in handy again. So let's talk about our domain. Domain are the x's. In our case, the number of customers. X is
0.
not 0, but greater than 0. X's are greater than 0. Now, what do I mean when I say the x's are greater than 0?
That could be anything. But 0?
Well, remember, x's represent the number of customers. And all that's saying is I could have 1 customer, 2 customers, 3 customers, 4, 5, 6,
All the way up to 24.
anything bigger than
24.
0. Well, no. So we're talking about customers. We're not talking about muffins. So we can have 24, we can have 25 customers. We can have 26 customers. But the next one, the range, now we are talking about muffins. Okay? So what do you think for the range? Talking muffins now.
Less than.
Less than what?
24.
All right, very good. Now, you got to add a little bit more to that, because if I just say less than 24, which is true, then I'd also be talking about negative numbers. And can we have negative 5 muffins?
No.
No. So we're only talking about positive numbers, correct?
Yes.
All right, so here's how we're going to write this. We're going to say that
Oh,
the range is between
Oh.
0 and 24. So 0 is less than y, less than or equal to 24. All I'm saying there is the number of muffins we're giving out to each customer is going to be somewhere between 0 and 24. That's what we're saying. We're including that 0 part because we want to make sure we leave out negative numbers. All right, let's decide. Do we have a function? Is this a function? Yes or no? Yes, we can call this a function. And the reason we're going to call this a function is because each x value has one unique y value. In other words, if there was only one customer, they get all 24. If I had 2 customers, is it possible for each one of them to get 24?
Yes.
If I had 2 customers?
Oh,
No, of course not. So they have a different y value. So depending on how many customers they have, they'll have a specific and unique y value. What do you think on this one? The last one we saw, it was increasing.
Decreasing.
Is this one increasing?
Decreasing. D.
Why do you say decrease?
Because the more people that come, the less the people.
Ah, that's perfect. That is right. This is decreasing. Decreasing. And the reason we're saying it's decreasing is because the more people, the more customers, the fewer muffins they get. As the x's get bigger, the y's get smaller. As x's get bigger, y's get smaller. As the number of customers increases, the number of muffins they get decreases. All right, continuous or discrete. Can I connect the dots or not connect the dots? I'll tell you what, let's raise our hand. Those of you that say, yes, this is continuous, we can connect the dots. Raise your hand if you say continuous. We can connect the dots. Got one. How about discrete? How many say, no, we can't connect the dots? All right, and the rest of us have no clue. Well, luckily I had more hands for discrete because discrete is the correct answer. Discrete is the correct answer. Now, if you remember on the last one, we also said it was discrete, and that was because we couldn't have a part of a muffin. Well, now we're saying it's discrete because you can't have part of a person. You can have 1 person, 2 people, 3 people, but you can't have 3.5 people. So this is why we're not connecting parts. There is no such thing as a partial person. Even if they're missing their legs, guys, they're still a person.
Unless they're like chocolate.
Not even then, they're still a person. Still a person. All right, now let's fill out the table here. Now remember, this is a little bit different. Our x values. Those x values represent the number of customers. The y values, they represent the number of muffins they get. So let's think about this. If there's only 1 customer in line, how many muffins are they going to get? They get all 24. All 24. But if there's 2 customers, each one is going to get 12. If there's 3, you're going to get 6. What if there's 4 customers?
3. Wait. 3. Am I right? No, wait.
Guys, how many muffins are there? There's 24. And we got 4 people in line. Yeah. 2. Let's go back. Watch this, guys. Watch this. Let's do this
Wait, we're
again.
halving them, right?
1 person. No.
Oh.
If there's only 1 person in line, they get all 24. If there's 2 people in line, each person gets 12. Now, let me stop right there. How did we come up with that 12? We have it. And why did we have it?
Because there's 2 people.
Because there are 2 people, so we divided it by 2. What if there's 3 people?
8.
8. 24. Each person is going to get
8. I knew it was 8.
8.
Because that's divided enough.
24 divided by 3 is 8. Each person gets 8 muffins. What if there's 4?
6.
Huh? 6. 24 divided by 6 is 6. What about 5? What if there's
4.8.
4.8? That's not really going to work because you can't really get 0.8 muffins, can you? No. Let's go to the next one. 6. What if there's 6 people? How many do they get a piece? Let me finish here and then you can go. How many? 4. Okay. Let's do one more here. What about 7? 7. There's 7 people in line. How many do they get a piece?
0. 2.4.
3.4. But again, can you really give out 0.4 muffins?
You have to give out crowd.
Now, this last one here,
24x.
nope, that was the other. No, wait. Slow down. These y values, this 24, the 12, the 8, the 6, the 4, what exactly did we do to come up with those y values? We divided. What did we divide?
2. 24.
24. We took 24 and divided it by 2. Then we divided it by 3. Then we divided it by 4, and so on. So all we're doing is taking the 24 muffins and we're dividing it by the x. So 24 divided by x is what we have this time. 24 divided by x. Now let's graph, just like we did earlier on the first situation. These x values, what are those x values? They represent the number of customers. That's the number of customers. The y values, that's right over here. These are the number of muffins. So the x's are the number of customers. The y values represent the number of muffins they get. Now we need to figure out what we're going to count by. Notice I'm going from 1 to 7.
1.
We're going to count by 1. I think we have enough room. Yep, just enough room to get all 7 in. However, when I get to the y values, notice the largest y value we have is a 24. So what are we going to count by so we can get to that 24?
24.
No, what are we going to count? We're going to count 2, 4, 6, 8.
4.
We're going to go 1, 2, 3, 4.
4.
4.
Wait.
I don't think we have enough room to we can 2, right?
4.
4. Okay, let's try 4. Let's see if that'll work. So then we got 4,
8, 12,
8, 12,
16,
16, 20, 24, and 28. Look at that.
I'm so bad at math.
Just-
We're just so good.
Now that I've got everything labeled, now we're ready to start actually plotting the points. And the first point we have is 124. So let's find that first order pair, 124, and plot it. The next point we have is 212. So let's find 212. Then we'll plot 3 8s. What is that? 4 6. Now 4 6, we're going to have to just kind of estimate it here somewhere between the 4 and the 8s. 5 and 4.8. I'm going to skip over that one because, like I said, you really can't have 4.8 muffins. So let's do 6 4. 6 4 is right here. And then I'm also going to just leave out that 7 3.4. Okay. So here's what we have. Be careful before you answer this next question. Would it be okay for me to connect the dots?
No.
No. Remember what we said earlier? We said it was, where is it at? Discrete. And when we have discrete, we're not connecting the dots. And why did we say we weren't going to connect the dots? There you go, because you can't have half a person. So there's our graph. Now let's get a verbal representation of what's going on here. Here it is. Here's our verb. The number of muffins per customer. The number of muffins per customer. The number of muffins per customer is 24 divided by the number of customers. In other words, how many muffins you get. The way we're going to determine that is by taking 24 and dividing it by the number of customers we have in line. So now that we got the verbal, now we're going to see if we can do the algebraic representation.
24/x.
Well, remember, we need a y equals. So it's going to be
Y
y equals what?
24x.
Nope, but you're close.
24/x.
And what is the slash?
Divide.
Divide. Look, guys, look. What we have right there. Y divided by 24x. This is our rule. This is our pattern. Take a pass. So the way we came up with those y values is simply by taking 24 and dividing it by x, which those x's represented the number of customers. That's all that was. Okay? Now, last page here has some questions that pertain to these two situations. So let's go and answer those questions real quick. Number one, which situation contains a linear graph? So everybody look at your two examples that we worked, and I want you to write down for me which situation contains a linear graph. You have two graphs, and you determine which one is a linear or line.
Or like a straight line?
Yeah, which one looks more like a straight line?
Situation one.
Which one?
Situation one.
All right, very good. That's the one that looks like a line, linear. Correct. The only one that has the lines are the points that line up in a straight line. Situation one. Number two wants to know which graph represents a situation that passes through the origin.
This is the origin of the
0, 0 is the origin. Which one of those would go through the origin? 0, 0.
Situation two. Situation one?
Because
Neither?
Look at your graphs. Look at
Neither.
your two graphs. Go. Look at your two graphs. Which one of those would also go through the order paired 0, 0? Which one would follow the pattern?
That one.
What?
One is one.
Situation number
It's right in the center.
1. Situation 1. And the reason we have situation 1 is if you think about it, our x values, those x values represented the number of batches. The y values represented the number of months. So in other words, if I had 0 batches, how many muffins would you have? If you had 0 batches, how many muffins would you have? 0. You would have no muffins. So 0, 0. 0 batches, you have no muffins. Number 3, which situation can be represented by the function written in the form y equals k times x? Something times an x. Look at the two algebraic representations we came up with.
First one.
First one, and what was it?
24x.
24x. There it is. Okay, so it's the first one. And that function we had was y equals 24x. 24x. Now, number 4 kind of goes with number 3 here. What does the function rule or equation tell you about the relationship in this situation? I need you to write down for me that it shows that it is proportional. This relationship is proportional. Proportion. portion. In other words, every time I make a batch, I'm always going to increase it by the same number, which in our case is 24. Okay, number 5 and number 6 you're going to do on your own. For number 5, without saying anything out loud, I just need you to write it down for me. You're going to tell me what were some similarities about situation 1 and 2. What did you notice that was the same? And then for number 2, you're going to tell me what was different about those two situations. So look at the 2 that we did. Tell me what you notice is the same, and then tell me what you notice
The
is
methods are the same.
Write it down. Don't say it out loud. I want you to write it down. First one is what is the same. The other one is what is different. What's the same, and then what's different. What's the same, and then what's All right, let's talk about some things that are the same. What did y'all notice is the same?
The methods. They both have 24.
They both had 24 muffins. Okay, what else? Come on, what else?
They both have 24.
They both what?
24.
Okay, so that's kind of the same thing we already have. Come on, let's hear some others. You don't see anything else they have the same?
No.
Look at the boxes we have.
They're both.
The first one.
They're both the same from the same bakery.
They're from the same bakery. What? They're both discrete. Both of these have dots that are not connected. Very good. They're not discrete. What else? Was the first one a function? Look at that.
X's don't repeat.
What? X's don't repeat. What do you call that when the X's don't repeat? A function. Did we say both of them were functions?
Yes.
No.
Look at your paper, guys. We wrote it down. Yes, it's the first situation.
Yes.
Was it a function? What about the other one? Was it a function?
Yes.
Yes. So this is also a similarity. So we have both of them are functions. They're both discrete, and they both have something called a constant. So these are some things that I noticed. You may have noticed some other things, and that's okay. You can leave those there, but we should have these. Now let's talk about what was different. What did you notice different about these?
Situation 2 was decreasing. Situation
Okay, very good. One is increasing, the other is decreasing. What else?
You're multiplying 24 situation 1 and dividing.
All right, good. One is multiplying, the other is dividing. Very nice. So we have one that increases, the other that decreases. You'll notice that one of them looks like a line, the other one looks like a curve, right? So one of them is linear, the other is not. That would be another characteristic that's different. And then the last one here says, why would situation 2 be considered an inverse relation? Now, we haven't talked too much about inverse relations yet, so just go ahead and put this down for me right now. X times y, xy, the product is 24. When I multiply the x times the y, I get 24. As x increases, y decreases. And we'll be talking more about the inverse relation probably tomorrow. Tomorrow and Wednesday. All right, so that takes us through Blue Bonnet Bakery. Blue Bonnet Bakery.
I'm done.